Hi everyone, and welcome back. So in the last video, we were able to publish and subscribe from the FC6A Plus PLC over MQTT to AWS. Now in this video, what we want to do is to automate some of that process. If you remember, we were using a custom monitor dialog box, and we had to manually go in and tell it to connect, manually go in and tell it to publish. The subscribe bits automatically do turn on whenever we connect to the broker, so there's nothing we have to do there. But let's go in and add just a little bit of logic into the PLC to automate that connection process and the publishing process. So let's get started. Let me get out of your way here, and let's bring up WinLadder. All right, so if you guys remember from the earlier videos, the little bit of code that we had was really just to read the thermocouple data, read the temperature, and convert it into a floating point, right? And once we had done that, we were able to go in, set up MQTT, and we used this dialog box, this custom monitor dialog box that we created, to physically go in and force the MQTT connection and force the publish bit on, and then watch everything happen. So like I said, let's go ahead and let's actually automate that connection process. So I'm on rung 1, I'll hit enter to make a new rung. And what I want to do here, let me scroll this up just a little bit, is I want to get a normally open contact, and I'm going to use special internal relay M8120. This is what we call the initialized pulse. I also call it the first scan bit. Basically what happens is whenever the PLC powers up, or right after you download a program, this internal relay turns on for the first scan of the PLC. So it's great for using it to initialize things, which is what we're going to do. So again, it comes on for the first scan of the PLC, and then it turns off. Okay, so it's only on for one scan. The next time you power cycle the PLC, or you download another program, or you take the PLC in and out of run mode, then that bit again will turn on for the first scan and then turn off. So what we'll do in this rung is we will initialize or clear out some of the data registers that we have been using. So for example, let's go ahead and clear out or set to 0 the connection status registers. If you guys remember from the earlier videos, that was D0 and D1. So let me go grab a move instruction underneath advanced, move, and move. And in here, again, my source is 0. I want to clear out these registers. My destination is data register D0. Now, I also want to write a 0 to the very next data register, D1. So to do that, what I can do is I can turn on this repeat checkbox here. And then in the repeat box, I can tell it how many data registers do I want to clear out consecutively, starting at D0. Well, in this case, I just want 2, D0 and D1. So that's what this will do. This will write a 0 to both of those data registers. Okay. Let's add a ladder line, and let me scroll this down just a little bit to bring it up on the screen for you. So let's do the same thing. We'll write a 0. We'll clear out our publish status registers, and we'll also write a 0 into our subscribe status registers. Just that way when the PLC starts up, all those are at 0. So if we go to monitor them, we don't have any false misconceptions about whether it's connected, whether it's communicating, what have you. We'll be able to easily see that it's 0 and there's nothing there yet. So we'll draw a ladder line down. Again, I'm going to do a move instruction. And again, my source 1 is 0. And if you remember from the earlier videos, our publish status data registers were D200. And remember, we used 4, so it goes from D200 to D203. So just like I did earlier, I want to go ahead and clear out those 4 registers. So I'll turn on this repeat checkbox and put a 4 in the repeat box. So that'll write a 0 to D200, 201, 202, and 203. Okay. And let's do it one more time again for our subscribe status registers. Put in a move instruction. Again, I want to write a 0. And if you remember, we used D300 through D303 for our first subscribe topic, which was FC6A/data. And then for the next topic, FC6A/new data, we used D304 through D307. So we've got 8 total registers. So to clear all of those out, again, I'll turn on this repeat checkbox and put an 8 in the repeat box there. All right. So again, when the PLC powers up, we're just going to clear out the connection status registers, the publish status registers, and the subscribe status registers. Okay, so far so good. Let's go ahead and hit enter to make a new rung. I do have an extra ladder line here on line 6 where I don't have any logic. That's fine. We can leave it. It won't hurt anything as far as the program or as far as the scan time or anything like that. But just to make it look a little neater, I'll go ahead and delete that ladder line since there's nothing there. All right, now on rung 3, what we want to do is we actually want to automate that connection process. Okay. Again, if you remember, we used data register D0 as the connection status register. And the second bit in D0 will turn on when it's connected, when the PLC is connected to the MQTT broker. So if I'm not connected, so if I get a normally closed contact, if I'm not connected to the broker, D0 bit 2 will be on. Okay. So if I'm not connected, excuse me, I said that backwards. If I'm not connected to the broker, this bit will be off. If I am connected to the broker, this bit will be on. So if I'm not connected to the broker, what do I want to do? Well, let me move this down just a little so you can see a little better. Let's go in and make a self-resetting timer. So if I'm not connected, every so often I want to try to connect to the broker. So let's do that. I'll grab a normally closed contact and I'll assign this to, let's use timer T0. And I did go in ahead of time and put in all these comments so you guys wouldn't have to sit and watch me type this to make the video a little quicker. So timer T0, we're going to use this as our broker reconnect timer. Okay. So when I'm not connected to the broker and the timer's not on, then I'll be running the timer. So let me go grab a timer. We use a 1-second timer. Again, we're using timer 0. And let's set this to, let's say 15 seconds. Okay. Now let's put a one shot in, a single output. And I'm going to grab a single output up. So when I see this happen, when this turns on, I want to do something. Okay. So what do I want to do? Well, in this case, I want to reset. So grab a reset output. I want to reset internal relay M0, which is what we use for the connection control bit. And you'll see why in just a moment. Okay. So let's reset that. And let's go ahead and reset our publish control bit. So again, I'll grab a reset. And if you remember, we used internal relay M200 for our publish control bit. Okay, so I'm going to reset the connection control. I'm going to reset the publish control bit. And now what I want to do is set, let me draw another line down there. I want to set just an internal relay, and I'll use M50 for this. We could have used any internal relay as long as we weren't using it and it's not a special internal relay. And this I'm going to use to attempt to connect to the MQTT broker. So once this bit turns on, then we're going to do something else. Okay. And again, let me scroll this down just a little bit. Okay. So now I've got M50 on once this turns on. So I'll use here a normally open contact of M50. And let me put in another timer. So once that's on, we'll wait a couple of seconds. So let me grab a timer. And this will be timer T1. Again, we'll make this a 2-second timer. So again, this will just wait for a couple of seconds. Let me put in another one shot, another single output. And what do we want it to do? Well, once M50 turns on, we want to try to connect to the broker. So we need to set, let me grab a set output here. M0, our MQTT connection control bit. And let's go ahead and reset M50. That way it's ready to be used again if it needs to. So let me draw a ladder line down here. And let's reset M50. Okay. All right. So let's kind of go back over this rung. There's a lot happening here. You certainly do not have to do it this way. This is just one example, one way of doing it. So again, what's happening here, okay? If we're not connected to the broker, and this is a self-resetting timer, so basically we'll get a blip every 15, just about every 15 seconds. You've got to take into account for the scan time and things like that. So just about every 15 seconds, we'll get a blip here, okay? So if we're not connected to the broker, every 15 seconds, as soon as we see these conditions turn true, so just once, it will reset the connection control bit, reset our publish control bit, and it will set M50. We use the one shot, that way these bits can then be controlled by something else. We're just doing this once when we see this happen. When we see M50 get set, then this will be on. The timer will time for 2 seconds. Once we see it elapse, then we set our connection control bit. That's when we really try to connect to the broker, okay? And we go ahead and reset M50 again so it can be used again, okay? So let's go ahead and download this part just to check it out and make sure it works. So let me go ahead and download this. And let's go into monitor mode. Go into the MQTT custom dialog box that we built. Let me scroll this up a little bit. Okay. So you can see I'm not connected. The 15-second timer is working. Okay. We turn on our connection control bit. Here we're negotiating with the broker. At this point, we're not connected. Remember, it's not a 4 yet. Okay. And it looks like after 11, 12 seconds, something like that, it turns to 4 and connects to the broker. Now, this timer, the reason I'd set it at 15 was just to give it ample time for the PLC and the broker to negotiate the communications and for the broker to confirm the PLC is a valid device, it's a valid thing, it's got a proper certificate, all that, and then let it connect. So what can happen is if you set this timer to too short of a time, say if we'd set that to 5 seconds or something like that, what we may have seen happen here was it may go from 2 to 4 to 8 and then back to 0 again. So it may try to connect, but if we don't give it enough time to connect to the broker and for all that process to happen, then we could be sitting here trying to connect forever, and it just won't if we don't give it enough time. So 15 seconds in this example seemed like it was long enough. It looks like the broker connects after 11 or 12 seconds, so that's fine. So we are connected. Awesome. So let's go ahead and automate one more thing. And let me hit enter here. I'll make a new rung. And let me get rid of that empty ladder line there. Okay. So what we want to do now is we want to automate the publishing process. So how often do we want to publish our temperature data? Okay. So let's do that. Let me put in a normally open contact of D0 bit 2. Okay. So if we are connected to the broker, then let me create another self-resetting timer so we get a blip every so often. And again, I can do that by going to basic, normally closed, and I can use the address of the timer. And in this case, it's going to be timer 2. And again, I put these comments in ahead of time. So this is our publish control bit timer. We go grab the timer. Timer T2. And let's do this, say, every couple of seconds, for example. Okay. And then what we want to do here is grab a one-shot, a single output. Again, so when we see this condition turn true, let's go ahead and set internal relay M200. And again, that's our publish control bit. Okay. So every couple of seconds, once we're connected to the broker, we'll set this bit to publish the data. So what's happening is we're pushing the temperature data to AWS every couple of seconds. Okay. Now, again, on the subscribe, we don't have to do anything on the subscribe because that is automatically going to get turned on by the broker once we connect. Okay. So let's go ahead and download this. Then we'll go back into monitor mode. Let's bring up our custom box here. Okay, and here again, let me zero out this data register D1000 that we're using to receive the temperature data back from AWS. You remember we did that in an earlier video. That way we can see once we connect, we should see this value update with whatever the temperature is. And there it goes. Okay. So again, M200 here, we're turning this bit on once every couple of seconds. And again, we're doing it with a one shot there. And then the broker, once it sees that it gets published, the broker is getting this to reset. Okay. So this is resetting for us automatically. We don't have to go in and reset that bit. Okay. But we can see here we're publishing the temperature data every couple of seconds and we're receiving it. We subscribe to that data and we're receiving it back into the PLC in data registers D1000 and D1001. Okay. We can also check this in AWS. So if we go to a browser and we log into our AWS account, if you remember, if we go to IoT Core, okay, we can just search for IoT Core. Over here on this left-hand menu, we can go down to Test, and then we can subscribe to the FC6A/data topic. And then any messages that are getting published, we should see. And again, we're pushing this data out of the PLC every couple of seconds. So you can see the timestamp here. Every couple of seconds, we're getting a new message. Okay. So we can see that the automated process of connecting to the broker was successful. We've automated the publish process. And again, once we connect to the broker, the subscribe bits in the PLC automatically turn on. So we're receiving data as well. Okay. Now, one other thing that we could do in the program to further automate this a little bit quicker, right now we've got to wait, about 17 seconds went from the time the PLC powers up to the time that it connects to the broker, roughly in there. Because if we're not connected, then we wait 15 seconds before we start doing the process. Something else that we could do if we wanted the PLC to immediately start this process whenever we downloaded a program or the PLC power cycles, we could put in another line of code here, and it would be a really simple one. What we could do is put in a normally open contact down here of special internal relay M8120. Again, that's our initialized pulse, and put that in parallel with this instruction set. Okay, so when this is true or when this is true, this process will happen. So now when we download this, we'll go into monitor mode and check it out. But what we should see is as soon as we download and we can get into monitor mode, we should see that the PLC is trying to connect to the broker right away. So let's download that and check it out. Okay, so I've downloaded the code. Let me go into monitor and I'll open up that custom monitor dialog box again. And you can see we're already negotiating here with the broker, right? The connection bit is on, and there's a 4. We're connected, and we're publishing and receiving data. Okay. So that's it for this video. In the next video, what we'll do is we will take a look at how to create an Ec2 instance on AWS. So far what we've done is we're able to publish to AWS. We can get the data there. Now we want to take that a step further and set up an Ec2 instance on AWS so we can install Node-RED and we can build a dashboard so we can actually see this data and do some more stuff in the logic that we can actually control the PLC as well. So if that sounds of interest to you, stay tuned and we will see you on the next video.